All right, for this part, we're going to be talking about transformations. So the two functions we're dealing with again are the square root and the cube root. And if you're wondering how I can tell the difference, it is because the index here is not a given number, so we assume it is 2. This one has a 3, so I know that is the cube root of this. Now you'll notice they have the same 3 letters, A, H, and K. So here it says, how does changing the number in front of the square root of x or cube root of x affect the graph, in this case, the a value? So the a value actually has 3 transformations. So if you recall from earlier in the year, we did transformations a lot, and this is going to be the same thing. So if your a value is greater than 1, that is going to be a vertical stretch by that a value. If your a value is between 0 and 1, so less than 1 but greater than 0, that's going to be a vertical compression by a. And last, if a is less than 0, which means it's negative, it's going to reflect across the x-axis. All right, how does adding or subtracting a number inside the square root affect the graph? So now we're talking about the h value. So the way that h affects it, and you got to remember this is the opposite of what you see. Let's just put that there. So here we've talked about if h is positive, let's change it. Let's keep it consistent. If h is positive, which means it would be any number greater than 0. Now, this is assuming that I'm looking at it here. So if this number is positive right here, then that graph actually moves to the left h units. All right. If I'm looking at the h value here, and this number is less than 0, it's the opposite, so it actually moves to the right h units. So once again, I'm comparing this number here, so it's the opposite of what I see. So if I saw x plus 4, then it goes to the left 4 units. If I saw x plus 3, or sorry, x minus 3, it's the opposite, so it's plus 3, so it goes to the right 3 units. So if it's positive, it goes to the left. If it's negative, it goes to the right. And for the last one, how does adding or subtracting a number outside the square root of x affect the graph? So now we're talking about k. And k is pretty straightforward. It is what it is. If k is positive, then it goes up k units. If k is negative, it goes down k units. So up and down. That's pretty straightforward. Now I'm going to just kind of look over this example here and show you how to do these types of problems. It says, using the table of f of x equals the square root of x as a guide, describe the transformations and write the transform table of each function, state the domain and range. Okay, so as we go through this, let's refer back to this really quickly right here, these transformations, and let's talk about what they affect. So if we're talking about what affects domain, so for the square root function, the only things that affect domain are going to be things that move it to the left and right. So h, so left, right, and a reflection across the x-axis. Or sorry, reflection across the y-axis. So the reflection across the y-axis would be a negative sign in front of the x inside the radical. So what affects the range? So that would be, if this was left-right, what would affect the range would be up and down. And if this reflects across the y-axis affects the domain, then reflects across the x-axis affects the range. Okay, so let's go ahead and take a look at this back over here now. All right, so we're given the parent function of the square root function, or the table of the square root function, and now we have these transformations here. So the first thing we're going to do is we're going to list each one. So when I make a comparison, remember transformation, so I'm just going to write it here so I don't have to keep referencing back up there. So the first thing I'm going to compare is A. So the A value is 2, that is bigger than 1, so therefore that's going to be a vertical stretch by 2. The H value inside is negative 4, so the opposite of that is positive 4, so it actually goes to the right 4 units. And last K is what it is, so it says positive 3, so it's going to go up 3. So when I make tables to figure out the domain and range and what the graph would actually look like, so what I tend to do is write a rule. So the rule for this would be what affects x and what affects y. So the only thing that actually affects x is right 4, which is plus 4. So right above it, I'm going to put x plus 4. And what affects y is anything that's vertical. So vertical stretch and up 3. Those are two things that affect vertical. The vertical stretch multiplies to the y, and the up 3 adds to the y. And those are the two transformations I'm going to use to create my table. So what this tells me is, going back to the original parent function table, I'm going to add 4 to each x value. So in this case, it would be 0 plus 4, 1 plus 4, 4 plus 4, and 9 plus 4. And I just add them. 0 plus 4 is 4, 1 plus 4 is 5, 4 plus 4 is 8, and 9 plus 4 is 13. When I'm working out the y values, what this tells me to do is multiply each of the original y values by 2 and then add 3. So in this case, 2 times 0 plus 3, 2 times 1 plus 3, 2 times 2 plus 3, 2 times 3 plus 3. So 2 times 0 is 0, 0 plus 3 is 3. 2 times 1 is 2, 2 plus 3 is 5. 2 times 2 is 4, 4 plus 3 is 7. 2 times 3 is 6, 6 plus 3 is 9. And then from here, I would just make my graph from here. So 0, 1, 4, 9, 0, 1, 2, 3. Just gotta make sure I do this right. Yeah, it looks good. If you couldn't see the domain from this, you can always just make a quick rough sketch. So I'll just do that so you can see what it looks like. So 4. And what you will notice, I'm just gonna do a quick rough sketch here. You'll notice that you can see, so 1, 2, 3, 4, and then up 1, 2, 3. Then we go, we see we have 5, 5. And then we have 8. So 1, 2, 3, 4, 5, 6, 7, 8. Then we have 7. So we can see our graph is looking something in this manner here. All right, and so we see that this point right here is where we start to figure out our domain and range. So to our domain, it went to the right 1, 2, 3, 4, and that was our transformation. So that's going to be 4, 2, and we can see it's headed towards infinity. And for your range, we can see that it went up 3 units and it's still going up. So that's going to be 3 to infinity. And so, yeah, that's how I would do this here. You can make a rough sketch, or you can just look at the transformations and know that it goes right 4, up 3, because we talked about transformations, how they affected it. Left and right affected the domain, so it went right 4. That's why my graph now starts 4 to infinity, because there was no reflection across the y-axis. What affects range is up, down, or reflection across the x-axis, so we had up 3. So notice the vertical stretch may have affected the graph, but it did not change the range.